Hi everyone, and welcome to our next presentation. This presentation is building elegant API contracts from zero to hero, where you will be learning how to write efficient APIs with high quality API specifications using Open API and RAML spec to create API contracts and achieve a better experience using the API with more reliable unit tests and increased response consistency. About the speakers, we have Neeraj, who is a senior at Ashoka University. Over the years, he has worked on a variety of full stack software and data science applications, as well as computational arts and quantitative finance projects. He likes the challenge of creating new tools and applications, and we would like to thank you, Neeraj, for being here today with us.
Thank you
And
so much.
it's all yours. You can start your presentation.
Okay, so hello everyone. So the session is on building elegant API contracts from zero to hero. First of all, hello, I'm Neeraj Pandey. I am a senior student at Ashoka University where I'm pursuing computer science and economics. And I'm also a generative artist. And if you talk about my background, I come from computational arts, quantitative finance, full stack web and data science applications. And yeah, that's pretty much all about me. So if we dive into the talk, these are the points for discussions. We're going to be talk about the elements and principles of how APIs work. We're going to talk about the stateless versus stateful architecture and which one is better and not. We're also going to talk about the contract first and code first approach and see when is more applicable to use and when is not, and why a single source of truth is important in developing a good API system. And once we have that information, we can deep dive into the API contract information. And with this all theoretical knowledge, we're gonna see some examples using Swagger UI, Postman, Flask, and Fast API. So API stands for Application Programming Interface, and it's a collection of guidelines and procedures for creating the integrating software. So it's nothing more than a messenger who tells your system that, hey, what do you want? And just waits for the response. And if you see, like, majority of our interactions on the internet are with the APIs from, like, it ranges from maybe booking a movie ticket on a Sunday evening or just like sending a text message on Slack to your friends. So API is essentially interfaces that allows applications to communicate back and forth. And you might be wondering, why are we discussing this? And because we know how API works and what is an API. But being a developer, I can say that, like, we have seen a lot of unexpected API behavior, which is something no one wants to say. And when this happens, like, what we do is, like, we go to the internet, we sometimes curse the documentation, we just like shout on the developers, maybe you rage on the Twitter, that's a thing. And if you don't get any solution, that's the last talk is the Stack Overflow. We get this answer over there. So we can say, like, as the technology advances, so does the usage of API, and which necessitates the better design approach. So to understand these API contracts better, we first need to understand how APIs actually work and what are the principles behind that. So the first one is, like, it should serve a purpose. Like, an API is, like, first and foremost an interface for the people, and it should be it should have a usability. Like, if all the representations in our API, it should be intuitive, which means, like, everyone should be able to grasp all the names and other information at our first glance. You don't need to, like, brainstorm just like using how to use an API. And the API interaction should be as simple as possible, because a useful flow ensures that procedures are run quite smoothly, which allows user to, like, get the intended result very flawlessly. So as a result, we can say, like, there is a need of API system that is consistent across all standards and practices, which also allows for the seamless interactions. And we can say that we are also concerned with the API's flexibility so that it doesn't complicate with the things, and instead allows user to pick their own representations. But there's one more thing, like, which most of us don't even consider, like putting constraints on the API, because it says, like, imposing limits on the successful API design, because it's a good idea or a good practice to concentrate on usability, because it must be done by taking into account that the fact that the design must be restricted. A good example is a rate limiting thing, because you don't want spammers just like knocking off your API again and again. And yeah, when you talk about APIs, we usually talk about REST APIs. We don't talk about SOAP that much in 2021. And if we just talk about in general software engineering, we know that stateful application needs to be stored more data, which is mostly client session data. And on the other hand, if you talk about stateless, it doesn't save any kind of information on the client on the server, which is basically a client sessions data. And we can think of the same thing in API design, as REST APIs are stateless and provides a great deal of seamless integration and allows for easier version updates and development. So the question is like, why do we frequently find unexpected API behavior and poor documentation, which often leads to poor user experience and unit testing? And both monolithic and microservices, we're not talking about just monolithic here. Even the thing is like, we are trying our best because we are working so well in order to develop fantastic RESTful API, but still we are getting this kind of problem. So this brings us to an approach called code first versus API first. So if you talk about the code first, it's when using a code first strategy, uh, say once the business requirements are completed, the developer jumps right into the coding part. And if the API has like very few endpoints, or if it has been used for internal purposes, it completely makes sense to just like deep dive into the code and not design any kind of contract or any kind of proper documentation. But on the other hand, if there are like hundreds of thousands of endpoints and numerous people are working on it, major complications arise. And one of the most prevalent issue, I would say, is the problem of bottlenecks, which arises like uh, when developers use a waterfall paradigm, because what we're doing in an API first, we are trying to work in vertical slices, so we're using an agile environment. And what it does is like it prevents developers from working in parallel. And not to add that there is no much documentation, because it's going to be an extra thing once your API is already in place. But when you talk about the API first, it's something, on the other hand, which converts the plan into a human and machine understandable contract first, such as a Swagger document, and then only the code is being generated. So the contracts may be used to build mock servers and APIs, which allows the developers or the users to test the API ideas without putting them into production. So that's a very good thing. So this method can also increase something like an API adoption and consumption, which also improves the developer experience up to some level. And this method, like API first, can increase the API, say like the primary distribution of the API, and which is basically something the consumers may consume the services, and they can select the API design first approach. And so this is kind of like a crucial goal for us. And moreover, it also reduces the development cost, because we here we're using a lot of components again and again. So, and not to mention the risk of failure is also less in API first approach. So we are talking about API first, which talks a lot of about something called a single source of truth, or everyone, including machines and humans, should be come up to a point. And if you just like go to, like, by curiosity, you go to Wikipedia, you see like a single source of truth is the practice of structuring information models and associated data schema such that every data element is mastered in only one place. So it doesn't make much sense. So in layman's term, it's something that everyone, including humans and machines, agrees to, which is we call a contract. And it might be an agreement between your backend engineer or your front-end engineers, or maybe the maintainer of the project, maybe someone's just like randomly writing the documentations, or even a software architect, and the entire team. So we can state that information should not be repeated in several locations. So that's why we need a single source of truth in order to minimize mishaps. So that brings us to the final thing, which is API contracts. So as we have already discussed what are API contracts in API documentation, and I'll elaborate it a little bit. Like this document is where you basically specify your API functioning, how it endpoints will be, how the URLs will be, how each endpoint is going to function, the arguments and all those stuff. And I believe like in a development kind of environment, in a development team, these are very crucial. And the contract is created by the service providers and is intended by the API users basically, and or the firms or the developers that are utilizing the API. So when changing an API, any changes should be notified and recorded to avoid unexpected behavior from clients that consume it. This is where contracts come in useful, and they're quite handy. And it's very crucial to make sure that API contract is up to date and correct for everyone, because what's the use of it if it can't do that? And there are three main specifications we use. Like one is our API blueprint, which is of a markdown format, which is MSON. So it has a compatible to something similar to markdown, and it also follows all the open source tooling system. So it's quite an ideal thing for API for strategy. Then we have a RAML thing, and RAML stands for a RESTful API modeling language, and it has a single YAML kind of format. So it's also widely used, but the most widely used, maybe because of the Open API initiative, it's the Open API, which was previously known as Swagger. It has both the JSON and YAML format, and it's like very quickly to understand, and it's the widely used one. So in this, for the sake of simplicity, we're gonna be using Open API and Swagger for the entire presentation. So if you just like go deeper into the Open API specifications, we want to know, like, you must be wondering, like, we should know more about the API guidelines first before actually building something. So as I previously explained, like Open API contracts are built using API first principles, which makes it very simple to operate, and which also helps developers work in parallel and saves money. So furthermore, developers go to the Open API standard contract and determine what the parameter name should be, as well as the answer should be, and then only they establish the contract and the contract annotations basically, which are then added to your code structure, and then in an automatic manner they build a specific document. So moreover, we'll see this an example in the Flask one, when we'll be using a small web application in Flask. So moreover, by including sample replies in the specification, the spec may also produce a fake response, something we will discuss soon how we can do that in Postman or Prisma. And the fake server delivers a response that appears to come from a real server, but it's actually only a predefined answer in a code, and that's the user perceives as dynamic. And lastly, it also helps, which is kind of interesting, like it helps building server stubs, and the good part is like you can build it in your own preferred programming language. So I think this is good enough for the theoretical knowledge. So let's deep dive into the how to create one, the API contract. So we are using YAML because JSON is sometimes confusing with all the curly braces. So first of all, we start with a metadata, which is kind of an entry point for the Open API specification. We initialize with the version of Open API being used. Say we're using 3.0.0. Then we add our server endpoints. So here we are adding a local host, but it can be multiple ones depending on the type of application you're working with. And then you have an info block, and this takes all the information about the users and about the API, the versioning, etc., and then renders it. And if you just like run this in a Swagger UI, for instance, if you're using Visual Studio, there is a very handy plugin which you can use to just like inside the Visual Studio, you can just like create these Swagger UI outputs. So it says like, hey, this is a PyCascades mock API, terms and condition, this is a mock API, blah blah blah. Then the server is the name of the server which you're using. If you have multiple ones, you can switch it between back and forth, and there's nothing apart from, there's no filter tag, there is no paths defined. As path has said, we should know what path objects are. So because we are making an API, we will be having a lot of routes, and for example, if we have to define a endpoint, we can say like paths. Then we start with a root node here, because that's the path I'm trying to define over here. That's the route I'm working on, and it's a get request, so you can define your get or post request, what type of request you're working on. Then you see there is an operation ID which tells you what is the actual request you're working on. This is just for your info. and there's a summary you can add, there's a description. For example, here I'm saying returns a list of talks, and there's an option to add tags. So tags is basically just like classifies your routes, different type of routes, into different sections, so that's easy and gets handy for you to work around different kinds of endpoints inside your Swagger UI. Then the next thing is the parameters. So parameters is basically you have to define, these are like the scopes you pass in with your API request. So for example, here I'm saying, hey, this is a list size, and in is for your input. It says like, hey, is it going to be a query or is it going to be a path variable? If you would have used path, then it would have directly changed the parameters, the params, and it's updated with this input. And we have added a description. It's not necessary to add. Then we have also added the schema. And for example, here there is a spacing issue, that there should be one tab next after schema. So it should be of type integer. The format is int32. The default value is 1, and the minimum is 1, the maximum is 1. So we will have an option to just add those scopes to the API call. And as we said, like in the last slide, you see like we were adding parameters one by one, but instead, if you're having some similar parameters again and again, it's quite typical to have some features that utilize across several API. And while documenting an API in such scenarios, you may construct a snippet for such items so you can reuse them whenever you need them. So there comes this ref object handy. So we can just like create components outside the scope of the path, so that we can just, whenever we need that component, we need that object, we can just like call that parameter object and just like pass it to ref by using a hashtag in between. So yeah, that's another way of using reusable components, as we discussed earlier, like why API contracts come handy, and they can save a lot of money as well. And then the last thing is your responses objects. You want to show like what kind of response you're getting. So for example, here I'm saying, hey, it's going to be a 200, it's going to be a success message, and the description is going to be, hey, it works, success. And then you also maybe want to pass the content, what exactly you're getting back from the API. So it's going to be a JSON format, application/JSON. Then maybe you want to also specify what exactly the structure of the JSON will be. So I'm going to say, hey, the schema is going to be like, it's going to be a type of object, it's going to be a Python object, and it's going to have a property. Say it's going to be an output variable, which is going to be a string, and the key value thing. And for example, this is a return string. This is something we're gonna get back if you're going to use something like a mock server. And if you just like put them all together, you will see like I have added a path. Inside the paths, I have my root route, which is a get request ID and all that stuff we discussed already. And then there is a component which is outside the scope of the paths, and then we're just like using ref to call that component and the parameters. And if we just like run this, you'll see like, okay, something in the UI has been created which says like, okay, there's a parameter which says like page, and it's of desired length 1, the max can be 100. And if I get a success code of 200, it's gonna say like, hey, success, it works. And the example output should be something like an output, and which is like the value should be, this is a return string. So in order to understand this better, let's create a small API. And this is not going to be a comprehensive one, with very basic naive one. It's going to be like a mock API. So suppose you are at a conference, you know how conference works, speakers come, speakers talk, and maybe you like the talk and you want to vote for them. So how are you going to do that? Maybe you have just 3 routes. The first one is like the root one, where you can get all the information, all the details of all the talks. Then maybe you want to see each talk individually. You can just kind of pass the talk ID and get the talk details. Or maybe you want to vote for something. This is going to be a post request, and you're going to just like pass in the ID of the talk, and you're going to cast your vote. So first thing first, you're going to work with your metadata. So if you can see, maybe it's not completely clear, but like I'm just like adding a title, PyCascades voting version. I'm not adding over here. You can add something like 0.0.1. Description is there. Then the contact maybe of the developer. Then you can add a license. It's just a dummy thing. I'm just added like XYZ. It doesn't exist actually. So it's going to add some servers, like what the server endpoint is a local host, because my application will be running in a local host environment. And then I'm adding 3 tags just to specify different sections: details, single, and upvote. And the first path I'm creating is the root node, route, which is just like a get request, which is just like getting all the information. And I'm adding a parameter. I'm not using a ref because I'm not using it. So it's a query. If you see in, it's gonna say it's a query, so it's gonna just like send the parameter as a scope to the API request. And in the response, you can say I'm getting an array of objects, and each object is going to have a property which is gonna have 4 strings. One is a talk ID, one is a talk name, the talk speaker, and the talk pitch. And if you get a 404 error, it's gonna say, hey, no talk found on this URL. Similarly, we're gonna just like use to get a single talk detail, you're gonna pass the ID. The only difference you will see inside the parameters object, which says the in, the input is going to be the path instead of a query. So instead of just like passing it as a scope, it's gonna replace the ID in the URL with the value we're gonna pass as a parameter. And yeah, the follow XX I've used here differently because it's gonna just like all the for the 1, all these error codes will be just like replaced by talk not found, just for the sake of simplicity. And for the voting, it's gonna be very simple. The only difference in post request is like you also send in some request body. So it's gonna be like what kind of body you're trying to send. Is it gonna be application JSON? What's the schema? It's kind of same, but it's just like you send, instead of getting something, you are sending that information. And I've added multiple responses just to show you like how you can add multiple responses. Like if it's of 200, it's a successful vote, you can say, hey, your vote has been successfully cast. If it's a 404, you can say, yeah, that's an invalid input. 422, dude, don't be greedy, you have already voted for this talk. And 404 is like talk not found. Straightforward, isn't it? So if you just like run it on Swagger UI, you're going to see a single component with 3 different tags: details, single, and upvote. And you can just like click on any one of it. So for instance, if we click on the first one, which is the get request to fetch all the talks, you're going to see it's going to send a curl request, and you also see a requested URL, and then you see a status code of 200, and the response body is going to give you all the talks list from the server. And if you're not using anything like Visual Studio or the Swagger UI editor, you can also do it in Postman. The good thing about Postman is like it on the left hand side, it aligns everything. You can see like what exactly is the route, because these YAML documents gets very long. When I say they get long, I mean like thousands of lines long. So it's quite difficult to sometimes understand what exactly is happening. The good thing about Postman is like it creates a mock server, so you can, instead of just even building your API back in the API server, you can just like instantiate with a document the API contract and create this mock server, so that it can just like send you the pre-fed information, such that you can say, hey, this is working, so the test it's working properly, so the test completed. Suppose now if you're working on a web application, so you must be wondering how it's going to work like, because that's not something similar to the previous one. So the good thing about Fast API is it comes with a pre-built Swagger UI based tool, which follows all the Open API standards. So suppose I'm expecting like people know how web applications work in Fast API. So I'm not gonna go like how it's gonna be, how you can start working on Fast API, but like you can see like I'm just like calling the second route, which is like the get method. Get is like taking all the ID, sending in the ID, and getting the talk with the same ID. And if I go to the browser, if I say, hey, that's my base URL, whatever it is, and just like /docs, it's gonna give me a Swagger UI with all the things being taken on from my requested routes, which I've already created. Similarly, if you go to a Flask app, the difference is like Flask doesn't have any inbuilt library kind of thing, so we have to use some external tools. So here we're using API spec, and you can just like start with a spec equals to API spec, just pass in all the metadata kind of thing along with the plugins. And once you have done that, the only difference is like you use the same thing just like the Fast API, the route, but instead of as it's not creating anything by its own, you have to pass string literals and pass the YAML of the path. So it's going to be the same YAML you was creating in a YAML file, just like pass the path as a string literal. And the one more thing is, like, if you're working on this, you have to pass the spec each path of each route. And once you run this by saying base URL slash API, this is, if you can see, I've created a route specifically for the spec API spec. And if you hit that route, you will see like this API has automatically generated all the files into a JSON format, which you can use as your API contract. And I think it's almost time. So yes, thank you so much. I hope you like the talk, and if you have any questions, you can hit me up on Twitter. And if you want the slides, maybe you can take a couple of seconds and just copy this URL, or maybe I'll post this URL as well in the chat so that everyone can just like take the slides. And if you have any questions, hit me up on Twitter or hit me on the FAQ. Thank you so much. Yeah.
And I'm gonna say thank you very much, Neeraj, for taking the time to teach us about building elegant API contracts. As he indicated, any questions you can find on his social network. The next presentation will be cybersecurity investigation with Jupyter Notebooks with Ian Helen. We have a 50 minutes break right now, so we hope to see you all back here at 1:50 PST Pacific time. Also, don't forget to check out on the booth. Microsoft and PyLadies, both of them have a virtual booth right here in the venue list. Again, thank you very much, Neeraj, and see you later.
See you. Bye-bye.